By the end, you will have a deep research bot that searches the live web, reasons with DeepSeek-R1, and prints a cited report. This is for you if you already write a little Python and you are tired of one short chat answers with no sources. If you skip the loop, the model invents confident gaps and you ship a thin briefing that falls apart under questions. Picture Ember Vault, a research wire desk where every question travels out as a net, then DeepSeek-R1 reasons over what came back. The method is TIWL, target the question, retrieve with Tavily, analyze with DeepSeek-R1, weave cites, loop on gaps. DeepSeek-R1 is a reasoning model. It spends tokens thinking before it answers, which helps when sources conflict. Tavily is a search API built for agents. It returns clean page snippets instead of raw HTML you would scrape by hand. LangGraph wires those steps into a graph with memory. Nodes call each other until the reflect gate says we are done. You are not training a new model. You are looping search and reflection until the knowledge gaps close. Open the Tavily docs and find the search product. That is the retrieve door your agent will call. Open the DeepSeek API page next. We will call R1 through an OpenAI compatible base URL from Python. Open the LangGraph state graph docs. This is where target, retrieve, analyze, and loop become graph nodes. Open the LangChain Tavily integration page. The official package is LangChain Tavily. That is what we installed. Open a terminal and make a folder called Ember Vault under your project's directory, then move into it. Create a virtual environment so the research packages stay isolated from the rest of your machine. Activate the environment on Windows with the script's activate command or use bin activate on Mac and Linux. You will need two API keys, one from Tavily for search and one from DeepSeek for R1 chat. Open Visual Studio Code in the Ember Vault folder. Create an empty requirements.txt file. Type the first package name LangGraph. LangGraph is the graph runtime that runs target, retrieve, analyze, weave, and loop as connected nodes. Skip it and you have no state graph. Every later import of state graph crashes with modulo not found error. Keep the name exact so pip installs the same package we will import. Type the next line LangChain. LangChain is the shared toolkit for messages, prompts, and runnable helpers around the graph. Without it, node functions that build human message and system message will not import. We keep core LangChain beside LangGraph on purpose. Type LangChain OpenAI next. LangChain OpenAI gives us chat-OpenAI, which talks to any OpenAI compatible endpoint. We choose it so DeepSeek-R1 is one base URL change. If this package is missing, chat-OpenAI simply will not import and analyze, never starts. Type LangChain Tavily. LangChain Tavily is the official retrieve tool wrapper. We pick the official package over hand-rolled HTTP so search returns LangChain documents. Without it, you would fight raw JSON and lose the clean snippet shape TRWL expects. Type Python .env. Python .env loads your API keys from a local NV file so you never hard code secrets in Research Agent. Skip it and beginners paste keys into source. With it, load .env keeps keys out of Git while the script still finds them. Type Tavily Python as the last line. Tavily Python is the low-level client the LangChain wrapper relies on. Leave it out and retrieve can fail even when LangChain Tavily imports. Pin both so pip resolves the same stack we run on this desk. Install everything with pip install -r requirements.txt and wait until the packages finish. Create NV example. This file shows which keys the script expects without exposing your real secrets. Type Tavily API KY equals your key placeholder. This line names the environment variable Tavily leads for retrieve. Wrong name means search returns unauthorized even when your key is valid. Match TAVL wait API K exactly, then put the real key only in a private NV file. Type DeepSeek API PUI equals your key placeholder on the next line. DeepSeek API KY is what ChatOpenAI will send as the OpenAI API key when we point base URL at DeepSeek. If this is empty, analyze fails with an auth error before any reasoning tokens appear. Keep the real value in env, never in the graph file. Copy env example to a real env file on your machine, then paste your live keys. Do not commit the real env file. Create researchagent.py. This file is the whole TRAWL graph. Type from typing import typedict annotated. Typedict describes the research state as a typed dictionary, so every node knows which fields exist. Annotated will mark list fields that append across loops. Skip typedict and beginners lose the mental map of what target writes versus what retrieve returns. Type operator import for list append merges. Operator gives us operator add, so LangGraph can merge list fields by appending. Without that merge rule, each loop would overwrite prior sources instead of stacking evidence. Watch how we annotate sources later. Type importers next. OS lets us read environment variables for API keys. We choose the standard library over hard coding secrets. If this import is missing, getIn will crash before ChatOpenAI starts. Type the .env load import. Load.env pulls keys from your env file at startup. We write it first so every later client finds Tavily and these eek without hard coded secrets. If you forget load.env, keys look missing even when the env file exists. Type the LangGraph state graph and END imports. State graph builds the wire. END is the terminal edge when loop decides the report is dense enough. Without these two names, you cannot compile a runnable graph. That is the spine of TRAWL on this desk. Type ChatOpenAI from LangChain OpenAI. ChatOpenAI is the analyze brain client. We use it against DeepSeek's OpenAI compatible endpoint, so our one is one model string. Choose this over a vendor only SDK so the same code works when you swap base URL later. Type Tavily search from LangChain Tavily. Tavily search is the retrieve tool. Official package 1 invoke with a query string. If you scrape pages yourself, you spend days on HTML. With this import, retrieve returns structured snippets ready for analyze. Type load.env and call it with no arguments. This call runs once when the module loads, so both API clients see keys before the first node fires. Call it later and the first retrieve can raise empty credentials. Keep it near the top, right after imports. Type the research state, typedict with topic as a string. Topic is the target input, the research question the human typed. Every node reads it. If topic is empty, target invents vague queries and retrieve wastes search credits. Keep topic required and pass it from main. Add queries as a list of strings on the next field. Queries are the search lines target generates for Tavily. Analyze never searches blind. If this list is empty, retrieve has nothing to call and the loop stalls, so target must fill queries before retrieve runs. Add sources as an annotated list that uses operator add. Source stores URL lines from every retrieve. Annotated with operator add means loop appends new sites instead of wiping old ones. Without that merge, second, loop evidence replaces the first loop and weave loses half the trail. Add notes as another annotated list with operator add. Notes hold short analyze summaries after each retrieve. Weave reads the full notes pile for the final report. If notes do not append, later loops overwrite earlier findings and the report looks thinner than the searches you paid for. Add gaps as a list of strings for knowledge holes. Gaps are what loop writes when analyze still needs answers. Target on the next cycle turns gaps into new queries. Empty gaps means we can weave and END. Missing this field would force a fixed one, short path with no reflection. Type loop as an int field on research state. Loop counts how many research cycles we have already run. Without this counter, a buggy reflect edge can burn API budget forever. Watch the integer stay next to gaps, so should loop can read it. Type report as a string field on research state. Report holds the weave output you print at the end. Skip this field, and there is no finished win to show on the desk. Highlight report, so you know Weave writes here. Type lim equals chat OpenAI and open the parenthesis. This starts the analyze brain client object. We name it lim so every node calls the same R1 instance. Skip it and target, analyze, and Weave have no model to invoke. Type model equals DeepSeek Reasoner inside the call. DeepSeek Reasoner is the R1 chat ad on DeepSeek's API. Wrong model string means you talk to a non-reasoning chat model and analyze loses chain of thought quality. Match the name exactly on screen. Type API key from us getin DeepSeek API keyway. This pulls the DeepSeek key from your env file at runtime. Hard coding the key in source leaks secrets into Git. If getin returns none, chat OpenAI fails auth before any reasoning tokens appear. Type base URL pointing at API DeepSeek.com. Base URL steers chat OpenAI to DeepSeek instead of OpenAI's default host. Wrong URL burns the wrong vendor key or hits a 404. Keep API DeepSeek.com exact. Type temperature 0.2. Temperature 0.2 keeps analyze steady for research instead of creative fluff. 0 can get brittle. High values invent more. 0.2 is the teaching default you can tune later. Close the chat OpenAI call with a closing parenthesis. The closing parent finishes the client object so later nodes can call lem invoke. Leave it open and Python syntax errors before the graph ever builds. Watch the highlight on that closing line. Type search equals Tavily search with max results 3. This builds the retrieve tool with 3 hits per query. Max results 3 stays focused and cheap. 0 is the trap we demo next. Too many drown the prompt. Highlight max results 3 on screen. Type the target function header that takes research state and returns a dict. Target is the first TRWL node it plans search queries from the topic. Every LangGraph node must accept state and return a partial dict, wrong signature, and the graph refuses to compile. Type prompt equals and open a parenthesis for the multi-line string. We build the target instruction as one prompt string. A clear prompt keeps R1 writing queries instead of an essay. Skipping this means invoke has nothing useful to send. Type the first prompt line asking for 3 short web search queries. This tells R1 to emit search lines, not a full report. Without that instruction, target often returns paragraphs. Tavily cannot search 3 queries matches our teaching net size. Type an F string that injects state topic into the prompt. Topic is the human research question target must plan around. If you hard code a sample topic here, every run researches the wrong thing. Watch state topic fill the string. Type an F string that injects known gaps or none yet on the first pass. Gaps let the second target deepen after analyze. On loop 0 gaps are empty, so we show none yet. Without this loop can never feed new queries from holes. Type the line that says return only the queries, 1 per line. This stops R1 from wrapping answers in markdown chatter. Without it, split lines passing gets junk titles. Keep the instruction strict so queries stay clean. Close the prompt parenthesis. Closing the tuple style string finishes the prompt object. Leave it open and Python errors before invoke. Highlight the close so the prompt is complete. Type text equals lem invoke prompt, then take content. Invoke sends the prompt to DeepSeek-R1 and content is the plain reply text. Skip invoke and target never generates queries. Skip content and you hold a message object retrieve cannot use. Type the list comprehension that splits lines into clean queries. Split lines turns R1's reply into 1 query per line and strip removes bullets. Without this pass, you might pass a whole paragraph to Tavily. Watch queries become a real Python list. Type the return dict with queries sliced to 3 and the current loop count. Returning a partial state update is how LangGraph merges node output. We keep at most 3 queries and preserve loop, so should loop still knows the budget. omit return, and retrieve never sees new queries. Type the retrieve function header. Retrieve is the Tavily net. It runs each planned query on the live web. Same state in dict out contract as target. Wrong header and the wire cannot call this node. Type blobs as an empty string list. Blobs will hold the raw search nodes analyze reads next. Starting empty keeps this cycle's nodes separate until we append. Skip the list and you have nowhere to store retrieve output. Type cites as an empty string list. Cites store short source snippets for weave sources section. Without a separate cites list, the finished report loses the audit trail learners need to trust. Type a for loop over state queries. Each target query gets its own Tavily call. Looping keeps retrieve honest when there are 3 queries. Hard coding one search wastes the other plans. Type raw equals search invoke on queue. Invoke runs Tavily search for that query and returns agent ready snippets. This is the live web step. If invoke fails from a missing key, fix NV before blaming the graph. Type blobs append with the query label and raw result. Labeling each blob with QERY keeps analyze oriented when nodes stack. Skip append and analyze reasons over an empty pile even after successful searches. Type cites append with the first 240 characters of raw. We keep a short snippet for the sources trail without dumping huge HTML. 240 chars is enough to recognize the page. Omit cites and weave cannot show evidence chips. Type the return that maps blobs to nodes and cites to sources. Because nodes and sources use operator add, LangGraph appends these lists across loops. Wrong key names drop evidence on the floor. Match nodes and sources exactly to research state. Here is a common beginner miss. Watch what happens if max results is 0 on the search tool. Max results 0 means Tavily returns an empty net. Analyze then reasons over nothing and invents confident filler. That is the beginner trap. Fix it by restoring max results 3 before you trust any report. Fix the client set max results back to 3 on Tavily search. With 3 results per query, retrieve has real snippets again. Always check the tool constructor when nodes look empty. The graph can be perfect while the net is still closed. Type the analyze function header. Analyze is where DeepSeek-R1 reasons over retrieve nodes and lists gaps. Same node contract as target. This is the R1 brief step in TRAW. Type latest as the join of the last 3 nodes. We feed only the newest nodes so the prompt stays small and current. Joining with blank lines keeps each retrieve blob readable. If you send the entire history every time, you burn tokens and blur the latest facts. Type prompt equals and open the analyze prompt. Analyze needs its own instruction separate from target. A fresh prompt tells R1 to brief and list gaps. Reuse target's query prompt and you never get a gape section. Type the system style line that says use only these search nodes. From node stops R1 from inventing facts outside retrieve. Without that rule, we will cite fiction. Highlight OLY so the learner sees the guardrail. Type the line that asks for a brief and a gape PS section. The gape S marker is how loop knows what to target next. Skip asking for gapes and should loop always weaves after one pass. Keep both the brief and the gape as label. Type the line that limits gaps to up to 3 missing facts. 3 gaps keep the next target focused instead of an endless wish list. Too many gaps explode loop cost. 3 matches are 3. Query target style. Type the F string that inserts latest nodes into the prompt. Latest is the evidence R1 must use. Forget to include it and analyze briefs from an empty prompt. Watch the nodes land inside the string. Close the analyze prompt parenthesis. Closing finishes the instruction before invoke. Syntax must be valid or the node never runs. Highlight the close. Type text equals lem invoke on the analyze prompt, then content. R1 writes the brief and gapes here. Same invoke pattern as target If this fails, check the DeepSeek key before rewriting the graph. Type gaps as an empty string list. We parse gaze into this list for should loop. Starting empty means no second target unless R1 actually listed holes. Skip the list and you cannot root on gaps. Type an if that checks whether g apus colon appears in the reply. The marker must be present before we pass. Without the check, split on missing GPS crashes or invents junk lines. Only parse when the label exists. Type tail as the text after the gapus marker. Split once keeps the brief above and the gap lines below. Taking index 1 is the gap section. Wrong index would feed the brief into the gaps list. Type the list comprehension that cleans each gap line. Same parse style as target queries, one gap per line, bullets stripped. Dirty lines confuse the next target. Keep the clean list on screen. Type the return with the brief as a new note, at most 3 gaps, and loop +1. Appending the brief into notes feeds weave, gaps feed loop, and loop +1 spends budget. Forget loop +1 and should loop never hits the max. Watch all 3 keys update together. Type the weave function header. Weave writes the finished cited report, the open and close win on this desk. It runs when should loop decides gaps are done or the budget is spent. Type body as the join of the last 4 notes. Body gathers recent analyzed briefs for the final report. 4 notes cover at least one full loop of evidence. Too few and weave is thin, dumping everything can overflow the context. Type cites as bullet lines from the last 9 source snippets. These bullets become the sources section. 9 snippets cover about 3 queries times 3 results. Skip cites and reviewers cannot verify the brief. Type prompt equals and open the weave prompt. Weave needs a report writing instruction, not a query planner. A separate prompt keeps the final voice clear. Reuse analyzes gaps prompt and you get another gap list instead of a report. Type the F string that names the topic for the report. The topic titles the finished win so the report answers the human question. Hard coding a title here drifts from the real ask. Keep state topic in the string. Type the line that says use the notes and end with the sources section. Sources is the audit trail on the answer board. Without demanding it, R1 may omit cites, highlight sources, so weave always closes with evidence. Type the F string that attaches noti RC isnenpeats. Body and cites are the only evidence weave may use. Leave them out and the report hallucinates. Watch both blocks land in the prompt. Close the weave prompt. Closing finishes the report instruction before invoke. Same discipline as target and analyze. Highlight the close. Type report equals lem invoke on the weave prompt, then content. This is the finished brief string you print in main. If invoke fails here, keys and base URL are the first checks. Highlight report as the win object. Type the return that sets report and clears gaps. Clearing gap signals we are done reflecting. Leaving old gaps would tempt another target after weave. Report plus empty gaps is the clean terminal update. Type the should loop header that takes research state and returns a string. Should loop is the gate after analyze, it returns the next node name as a string. LangGraph conditional edges need those exact names. Wrong return type breaks the wire. Type if loop is greater or equal to 2. 2 cycles is this lesson's honest budget before we force weave. Greater or equal 0 is the second trap we show next. Keep 2 so a second target can still run when gaps remain. Type return weave inside that budget branch. When budget is spent, we weave even if gaps remain. That prevents infinite loops. The string must be weaved to match add conditional edges. Type if state still has gaps. Truthy gaps means analyze found holes worth another target. Without this check, you always weave after one pass. That is one short research with extra steps. Type return target when gaps remain. Returning target sends the wire back to plan new queries. Spell it exactly like the node name or LangGraph cannot route. Highlight target on screen. Type the default return weave when there are no gaps. No gaps means the brief is dense enough to finish. Defaulting to weave closes Tavily cleanly. Omit this line and Python returns none and the graph crashes. Watch the second trap, forcing weave, on the first pass by treating loop as already done. With greater or equal 0, the gate always weaves after the first analyze. Gaps never become new queries. That is one-shot research with extra steps. Restore greater or equal to so a second target can fill the holes. Fix should loop require loop greater or equal to before forcing weave. Loop budget 2 is back. Now the gate can still return target when gaps remain on the first cycle. Watch the highlight on greater or equal to. Type the build graph function header. Build graph wires every TRAWL node into one runnable app. We keep wiring in one function so main stays thin. Skip it and you have orphaned node functions with no edges. Type G equals state graph with research state. State graph is the LangGraph container type to our state. Wrong state type means node updates will not type check against fields. Highlight research state. Type add node for target. Registers the target function under the name target. The string name must match should loop returns. Mismatch and routing cannot find the node. Type add node for retrieve. Registers retrieve for the Tavily step. Same naming rule, keep retrieve lowercase to match edges. Type add node for analyze. Registers analyze where R1 briefs and lists gaps. Without this node, the wire has no reasoning step. Type add node for weave. Registers weave for the finished report. Skip it and should loop has nowhere to send a done run. Type set entry point to target. Entry point is where invoke starts. Starting at retrieve would search with empty queries. Target must be first. Type an edge from target to retrieve. After planning queries, we always retrieve. A missing edge leaves target's output unused. Highlight target to retrieve. Type an edge from retrieve to analyze. Fresh nodes must reach R1. Skip this edge and analyze never sees Tavily output. Type add conditional edges and open the call. Conditional edges let analyze choose target or weave through should loop. A plain edge here would delete the loop in TRAWL. We need the router. Type analyze as the source node for the router. The router runs after analyze finishes. Wrong source means the gate never sees gaps. Keep analyze as the first argument. Type should loop as the routing function. Should loop returns the next node name string. Pass the wrong function and you hardwire a broken path. Highlight should loop. Type the map from rote labels to node names. This dictionary must match the string should loop returns. A typo here silently drops a branch. Keep target and weave exact. Close the conditional edges call. Closing finishes the loop wire. Leave it open and Python syntax errors before compile. Type an edge from weave to END. END stops the graph after the report. Without it, weave may hang looking for another edge. Highlight weave to END. Type return G compile. Compile freezes the graph into a runnable app main can invoke. Forget compile and you return a builder object that has no invoke. Watch compile on screen. Type the main function header. Main is the desk entry build, seed state, invoke, print. Keeping side effects here means importing the module will not burn API calls by accident. Type app equals build graph. App is the compiled TRAWL graph. Build once per run. Rebuilding inside a loop would be wasteful. Highlight app as the runnable object. Type topic equals and open a parenthesis for the sample question. Topic is the research ask we pass into state. Using a variable keeps the string easy to change. Hard coding only inside invoke makes edits painful. Type the sample research question string. This is the finished win question from the open. Change it later for your own briefs. Keep it as one clear sentence Tavily can search. Close the topic parenthesis. Closing finishes the topic string. Same discipline as prompts. Highlight the close. Type result equals app invoke and open the call. Invoke runs the whole TRAL loop until end. Without invoke, you only have a graph object. Result will hold report and sources. Type an opening brace for the initial state dict. LangGraph needs a full initial state matching research state keys. Missing keys often crash annotated merges. We seed every field next. Type topic map to the topic variable. This injects the human question into state. Wrong key name and target reads empty, match topic exactly. Type queries as an empty list. Target fills queries on the first node. Starting empty avoids stale plans from a previous run. Highlight the empty list. Type sources as an empty list. Sources uses operator add, so it must start as a list. None here breaks the merge. Keep an empty list. Type notes as an empty list. Notes also append across loops. Empty start keeps the first retrieve clean. Same annotated rule as sources. Type gaps as an empty list. First target sees no gaps yet. Empty list means none yet in the prompt. None would be messier in the F string. Type loop equals 0. 0 means we have not spent budget. Starting at 2 would force weave immediately. Keep 0 for a real deep pass. Type report as an empty string. Weave overwrites report at the end. Empty string is a safe placeholder. None can confuse printers. Close the initial state dict. Closing finishes every research state key. Missing a brace is a syntax error before any API call. Highlight the close. Close the invoke call. Closing runs the graph and stores the final state in result. Leave it open and nothing executes. Watch invoke complete. Type a print banner for the TRAL report. A clear banner makes the finished win easy to spot in the terminal. Without it, the report blends into logs. Match this label on screen. Type print of result report. This prints the weave brief, the same win as the open answer board. If report is empty, we've never ran or keys failed. Read what prints here. Type a print banner for sources. Sources banner separates sites from the prose. Learners should match both banners before trusting the brief. Type a for loop over result sources. We print each site snippet on its own line. Skipping the loop hides the audit trail. Highlight the for. Type print dash and the first 200 characters of each source. Truncating keeps the terminal readable while still showing the trail. This is what you match to the site chip on the answer board. Type the name equals main guard and call main. The guard runs main only when you execute the file directly. Without it, importing research agent elsewhere could spend API credits by accident. Keep both lines together as one safe entry. Run research agent and wait. First target plans queries, then Tavily retrieve, then R1 analyze. Hold the report when it appears. Read the sources section. That is the weave audit trail. If gaps fired a second target, you should see new queries in the terminal before the final weave. That second pass is what makes TRAL deep. TRAL on one-line target plans, retrieve nets, analyze reasons, weave sites, loop closes gaps. Grab the free TRAL starter scripts in the description. The exact research agent file from this lesson. When the next brief lands on your desk, run TRAL before you trust a one-shot chat box. Then raise the loop budget only when the gaps still matter.